Hi, so today I'm going to do 11-2, chapter 11. If you have a math book, it's 647. And today we're talking about triangles. And you're going to want to write these things down because we're going to reference them a lot. So there's two ways to categorize or put into groups triangles. The first way would be by its angles, and the other way would be by its sides. For sides, we're going to be talking about length. I may not always say that, but we're talking about length. And for angles, we're going to be talking about the degrees. So just some things that you need to know. I'm going to go to a different page, but just overall, things that you should know. A triangle always has 180 degrees in it. They might be broken up different, but all three together will equal 180 degrees. If you were to take that triangle, if it were like string and you were to lay it flat, it would be a line. So that line also has 180 degrees, which helps you. If you have a circle, it's 360. I did a pretty good job drawing that circle, I must say. 360. If you cut it into half, either way, those lines are 180. That's why if you have a quadrant, you have a right angle, which is 90 degrees. So something you're going to remember is a right angle is 90 degrees. When someone says someone did a 180, that means they went from here to here. That means they completely flipped around. If you did a 360, you would have obviously come back to where you were. Okay? So, just some things we need to know. So we have angle, degrees, and we have sides. So, if I somehow skip some pages here. Okay. So if you have an equilateral triangle, oh, I messed up already. Okay, let's go with angles. Excuse me. So for angles, if you have a right triangle, that means it has a 90-degree angle. If you have an acute triangle, think of it as a cute little baby. That means the angles are less than 90. Acute means less than 90. Think of little. And then for obtuse, it would be greater than 90. Think of obesity. It has that same OB. That's why, because it's bigger than 90. Okay? So let's just kind of show you some pictures for this. If I have a right angle, usually it has that little corner line. If I take that farther, that would be an obtuse angle. And if I take it smaller, that would be an acute. You could also think of it like this. If you went extended farther than that 90, it would be obtuse. If you went smaller than that 90, it would be acute. Okay. For length, for side length, if all sides are the same, it's an equilateral triangle. That makes sense. All sides are equal, it's an equilateral triangle. If two sides are the same, it's an isosceles. And how I kind of think about that is there's two S's and two E's right there. Isosceles are two sides the same. And the last one is scalene, and that means no sides are the same. And it wouldn't just be the same, you would really be using the word same length. And how we show that, if I don't have like an actual ruler, all sides are the same, they all have that one. If I had a triangle where, but you can obviously tell that it's like equilateral. Let me draw a better one. If these two are the same, then that might have a different line. And if all of them are different, it might be like this to show they're all different. Those like hashes can show you that. So I'm going to take a picture. So this first one says 12 feet, 14 feet, 11 feet. I can already tell that's going to be a scalene. I'm just going to put S for scalene because all sides are different. And if I look, see how those angles are smaller than 90? So that's going to be an acute triangle. I'm going to not write the full words out, but please get used to those words. Actually, you know what? I should probably write them out so you get used to them. Okay, the next one. I can see all of those angles are the same and all of the sides are the same. So that would be acute because they're smaller, and it would be equilateral. The next one, I can see these two angles are the same, and that one's 29 degrees. So that's acute. And these two are the same, and that's different, so that would be an isosceles. Now this one, it gives you the actual numbers. So that 126 I know is obtuse, because it's greater than 90. 3.5, 6.2, 3.5. So I know that's going to be isosceles, because two are the same. For this one, we have 2, 5, and 3.8. So that's going to be scaling because they're all different. And then I see a 43, 116, and 21. I see one that's bigger than 90, so that's going to be obtuse. Okay, so this next one, circle the figure that does not belong. So there's a few ways to look at this. See how this has a right angle, this has a right angle, this is not. So I'm going to pick this one. That one does not belong because it does not have a right angle. I just want to make sure that I'm picking what the book picked. Yeah, and the second triangle does not belong because it does not have a right angle. Okay, let's do some more. We'll do this page and then, okay, so it says to write isosceles, scaling, or equilateral, and then acute, obtuse, or right. So looking at that first one, they already did it for you. It's scaling and right. And I can see because none of my sides are the same and there's a right angle. So this one, I see that 118. So that automatically tells me it's obtuse. And then I can see that these two are the same and this one would be different. So I can see that's an isosceles. Okay, for the next one, 50, 50. That one's really hard to see. This is 15. So I know that two are the same, so that's isosceles. And I see a 22-degree triangle, so that means it's acute. This one is easy to see. It's right. And I see a 24, 25, and a 7, so that would be scaling because none of them are the same. Let's see here. If I can move this up so you can see. So this next one, same thing. I see 44, 28, 24. So that's going to be scaling because they're not the same. And I see 110, 40, and 30. So even though 40 and 30 are acute, 110 is bigger. So it's obtuse. Next one, 23, 20, 13. That would be scaling because they're not the same. And all of these are less than 90, so this would be acute. Okay, so number 7 says, Mary says the pen for her horse is an acute right triangle. Is that possible? That is not possible because it's either right or acute, but not both. Karen says that every equilateral triangle is acute. Is this true? And if I can go to a picture of an equilateral triangle, let me think. I thought we had one. Oh, actually, right here, duh. If you can see, all of those are acute. So that would be true. Yes, all angles in an equilateral triangle are acute. Today's lesson was pretty short, so I'm going to go to the 6 questions that we always do. I would like for you to pause it before you watch the video and see if you can do them on your own first. Okay, so it says, if two of a triangle angles measure 42 degrees and 48, how would you classify the triangle? Write it as acute, obtuse, or right. So Oh, okay, I read that wrong, so I'm going to reread it. I'll make it bigger so you can see it, because I think that's why I reread it wrong. If two of a triangle's angles are measured 42 and 48, how would you classify the triangle? So this one's kind of silly because we didn't really review this. But I have to think about a triangle. A whole triangle has 180 degrees. So if one triangle length is 42, so can't do that. This becomes 7, that becomes 10. 10 minus 2 is 8. 7 minus 4 is 3, and bring down that 1. So then I'm going to subtract now 48. That becomes a 0, that becomes 0, that becomes 13. 13 minus 4 is 90. That means the remaining triangle degree would be 90. So that would be a right triangle. So they kind of trick you because I think they think you're going to put acute, but you have to remember, you have to think what are all three of those. So 90 plus 42 plus 48, so that 90 degree makes it a right triangle. Classify this triangle by isosceles, scaling, or right. Now, see, that doesn't really make sense because right is an angle, not a side. And scaling and isosceles are sides. But it's 4, 9, and 7. All of those are different, so that's a scaling. The next one, how many tons are equal to 4,000 pounds? So let's remember what we know. So 4,000 pounds equals tons. Remember, fly to horse, divide of course, and that's a division sign, even though it does not look like it. And you're going to divide by 2,000, or you can get rid of 3 zeros, get rid of 3 zeros. What's 40 divided by 2 would be 20. So 20 tons. Which is bigger, 6 kilometers or 6 centimeters? So I have to remember, King Henry died by drinking chocolate milk. For the by, remember it's grams, meters, or liters. So I'm going from kilometers to meters. So that's 1 jump, 2 jumps, 3 jumps. So let's change 6 kilometers, oh no, to centimeters, excuse me. 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps is how many centimeters? So that would be 5 jumps. Each of those is 10. So 10, 100, 1,000, 10,000, 100,000. So 6 times 100,000. Well, I know that's going to be 600,000, which is very much bigger than 600, so that would be the bigger sign. So 6 kilometers is bigger. Oops, what happened? And I have 2 more questions. Which polygon is shown? I just have to worry about how many sides. 1, 2, 3, 4, 5. I know that's a pentagon. And the next one says name the polygon and say if it's regular or irregular. It's regular because remember all of them are the same angles and the same side lengths. And it has 1, 2, 3, 4, 5, so it is also a pentagon. So it's a pentagon regular, or a regular pentagon, however you want to say that. If you want to go to Math Antics, I believe if you just Google Math Antics triangles, actually I'm going to do it as I talk to you. I believe I might put a link to that. He's going to explain it really well, and it's actually a short video. It's only 7 minutes, so you might want to watch that to get some more information. Okay, bye.